October 1932. The Caproni Company airfield near Milan. A tight crowd of engineers and military officials stands frozen in anticipation as something rolls onto the runway that defies every instinct they have about flight. Even seasoned aircraft designers cannot suppress murmurs of disbelief. What stands before them barely resembles an airplane at all. It looks like a gigantic flying barrel, a section of plumbing ripped from the ground and fitted with wings. The short, thick, perfectly cylindrical fuselage, painted in pale blue and cream, appears almost like a caricature of aviation itself. Tiny elliptical wings cling to the sides like toys attached to a drain pipe, but the most shocking detail lies hidden inside the tube. Suspended at the very center is the engine and propeller, completely enclosed by metal walls. 32-year-old test pilot Domenico Antonini slowly climbs into the cramped cockpit perched atop this aerial anomaly. Visibility is a nightmare. Massive bulges fore and aft swallow almost the entire field of view. Takeoff and landing promise to be an exercise in nerve control rather than skill. Antonini starts the de Havilland Gypsy 3 engine, only 120 horsepower, and something unexpected happens. Instead of the familiar deafening roar of a propeller aircraft, the flying barrel emits a strange, muffled rumble. Air is violently sucked into the front opening of the tube, driven through the spinning propeller inside, then expelled from the rear nozzle in a roaring jet. The machine shudders, begins its takeoff roll, and lifts from the ground with surprising ease. Everyone on the airfield holds their breath. The aircraft climbs confidently, its rate of ascent noticeably higher than conventional machines with similar engine power. Antonini circles the field several times, and all can see the impossible truth. This mad construction truly flies, and it flies well. When he lands safely 20 minutes later, a crowd of excited engineers swarms the aircraft. The pilot reports astonishing news. The machine is incredibly stable in the air, barely reacts to turbulence, and responds to the controls with unexpected obedience. The only drawback is that it is almost too stable, resisting sharp maneuvers and aggressive turns. Behind this triumph stand years of stubborn work by a man who dared to think in a way no aircraft designer of his era did. Luigi Stipa was born at the end of the 19th century into an Italian family of engineers. When the First World War erupted, the young student abandoned his studies and went to fight with the elite Bersaglieri, Italy's famed light infantry, recognizable by the rooster feathers on their hats. 4 years of slaughter in the Alpine trenches hardened Stipa's character, but did not extinguish his hunger for knowledge. After demobilization, he returned to study with renewed intensity, earning multiple degrees: civil engineer, hydraulic specialist, and finally aeronautical engineer. It was hydraulics that unlocked his revolutionary insight. Working with water systems, Stipa constantly encountered Bernoulli's principle, a fundamental law of fluid dynamics known since the 18th century. When a liquid or gas passes through a narrowing pipe, its velocity increases dramatically. One day, watching a powerful jet of water burst from a narrow nozzle, Stipa asked himself a forbidden question. What if this principle were applied to aviation? What if the propeller were placed not in open air, but inside a specially shaped tube? The air would be compressed, accelerated, and thrust should multiply. For the next 5 years, Stipa buried himself in calculations and experiments, producing dozens of drawings as he searched for the ideal tube shape, the perfect diameter, the correct narrowing at the center. By the mid-1920s, he arrived at a final configuration: a cylindrical fuselage with widened inlet and outlet and a constricted center section housing the propeller. The inner surface of the tube followed an airfoil profile, generating additional lift. Stipa called it the in-tubed propeller and published his findings in the prestigious aviation journal Rivista Aeronautica. By then, he was working at the Ministry of Aeronautics, rising to the position of Chief Inspector of the Air Force Engineering Department. One challenge remained: persuading the government to fund a real aircraft to prove his theory in the air. Italy in 1932 was gripped by ambition and a hunger for international prestige. The fascist government poured money into technological projects to demonstrate Italian engineering superiority, and aviation became the prime stage for that display. At exactly this moment, Luigi Stipa presented his radical tubular aircraft concept to ministry officials. The idea stunned them. It was futuristic, bizarre, and perfect for a propaganda triumph. Funding was approved, and all that remained was to find a company bold enough to build it. The choice fell on the aviation empire of Count Gianni Caproni di Toledo, one of Europe's most fearless designers. In 1910, Caproni had built Italy's first airplane. 4 years later, the world's first single-seat fighter with a forward-firing machine gun. During the Great War, his factories produced massive bombers that terrorized Austro-Hungarian positions. After the war, his reputation only grew wilder. His 8-engine, 9-wing passenger aircraft, the CA-60, became legendary, a 23-meter-long monster with a 30-meter wingspan designed to carry 100 passengers. It disintegrated and sank into Lake Maggiore on its first test, but failure never deterred Caproni. When the ministry proposed building Stipa's tubular aircraft, the Count didn't hesitate. The contract was signed in spring 1932, and work began immediately. Engineers faced a cascade of technical nightmares. The fuselage was a thick-walled cylinder nearly 2 meters in diameter, open at both ends. At the front, it flared into an intake, then narrowed sharply at the center to suspend the engine, before widening again into an exhaust nozzle. The inner surface of the tube followed an airfoil profile, generating additional lift. Stipa called it the in-tubed propeller, and published his findings in the prestigious aviation journal Rivista Aeronautica. By then, he was working at the Ministry of Aeronautics, rising to the position of Chief Inspector of the Air Force Engineering Department. One challenge remained: persuading the government to fund a real aircraft to prove his theory in the air. For the power plant, the designers chose the British de Havilland Gypsy 3, a reliable air-cooled inline engine producing just 120 horsepower. The engine was mounted in a special gondola positioned precisely at the narrowest point of the tube, where airflow velocity reached its maximum. The propeller was attached to the front edge of this gondola and rotated inside the metal cylinder, separated from the walls by only a few centimeters. The entire arrangement looked absurd, as if a child's drawing of an airplane had been brought to life in metal. To emphasize the experimental nature of the machine, it was painted in the bright blue and cream colors typical of racing aircraft of the era, which only made the result look even more comical. By early autumn, the prototype was complete. The aircraft received its official designation under the Caproni system, combining the names of the concept's creator and its manufacturer. On paper, the specifications were unimpressive: a wingspan of 14.28 meters, a height of 3 meters, a length of just 5.87 meters, a projected top speed of a meager 130 kilometers per hour, and an empty weight of 550 kilograms. By every conventional metric, the machine was inferior to standard aircraft of its time. Yet Stipa was convinced that his in-tubed propeller would demonstrate extraordinary efficiency and vindicate the theory he had pursued for 7 years. After the successful first flight, an intensive test program began. Domenico Antonini flew the strange machine again and again, probing its behavior across different regimes. The results were contradictory and, in places, astonishing. The flying barrel really did climb faster than conventional aircraft with similar engine power and wing loading. The inner surface of the tube, shaped like an airfoil, generated additional lift, confirming Stipa's theoretical calculations. But the most surprising discovery was noise. The aircraft was noticeably quieter than normal machines. With the engine and propeller hidden inside the metal cylinder, the sound was a muted hum rather than the deafening roar of exposed propellers. Pilots praised the aircraft's phenomenal stability. It seemed glued to the air, barely reacting to gusts or turbulence, a priceless quality for a trainer. Yet the downside became apparent almost immediately. Excessive stability turned every maneuver into a struggle. The airplane stubbornly resisted changes in direction, like a mule refusing to obey. Turns demanded enormous control forces and significant time. Aerobatics were out of the question. Stipa acknowledged a miscalculation in the control surfaces and was forced to nearly double the size of the elevators and rudder to restore even basic maneuverability. Speed tests brought disappointment. The aircraft struggled to reach 130 kilometers per hour, which was frankly inadequate even by early 1930s standards. The cause was brutal aerodynamic drag. The thick cylindrical fuselage plowed through the air like a blunt stake, generating massive parasitic resistance. Any advantage gained from the in-tubed propeller was completely canceled out by the tube itself. For a small, single-engine aircraft, this drag proved fatal. The machine could not realize its potential because of its own shape.
It was a closed loop. The tube increased propulsive efficiency while simultaneously choking the entire aircraft with drag. Stipa understood these limitations perfectly. The single-engine prototype had always been conceived as a flying test bench, not a combat or transport aircraft. He dreamed of massive multi-engine airplanes, where several in-tubed propellers would operate in unison, generating enormous thrust. He sketched numerous designs with 2, 4, even 6 engines mounted in separate tubes along the wing or fuselage. On paper, they looked impressive, promising unprecedented efficiency and payload, but they never progressed beyond drawings. The Ministry of Aviation allocated not a single lira for further development. The experimental prototype was deemed sufficient. After factory testing, it was handed over to military pilots for independent evaluation. The Italian Air Force conducted its own series of flights, measuring every parameter with methodical precision. The results sparked significant academic interest, but the military saw no practical value. Too slow, too unwieldy, too strange, the flying barrel was unsuitable for reconnaissance, training, or combat. Nevertheless, the test data were published in technical journals and quickly spread worldwide. The American National Advisory Committee for Aeronautics, NACA, studied the Italian work closely. Engineers overseas acknowledged the originality of the approach and the novelty of its solutions, while also pointing out the design's fundamental flaws. Stipa refused to give up. He patented his in-tubed propeller system in 3 countries, Italy, the United States, and Germany, detailing its operating principles, optimal tube dimensions, internal profile shape, and propeller placement. He hoped that sooner or later someone would recognize the potential of his idea and build a truly effective machine based on it. Meanwhile, the Italian government eagerly used the project for propaganda, publishing articles about the cutting-edge achievements of national aeronautical science. Reports on the Stipa-Caproni appeared in French, British, and German publications. The world learned about the strange Italian tube airplane, but no one rushed to repeat the experiment. The aircraft remained a one-off, slowly transforming from a technological breakthrough into a curiosity of aviation history as the ministry lost interest and shifted its focus to more conventional designs that could, at the very least, fly at respectable speeds.
Despite the cold reception from the military, Stipa's concept unexpectedly found passionate admirers beyond Italy's borders. The French Ministry of Aviation became intrigued by the idea of in-tubed propellers and commissioned the development of a full-fledged combat aircraft. Using this principle, the company ANF Muraux received a contract to design the BN-4 night bomber, intended to employ Stipa's tubular propulsion system. On paper, the project was ambitious: a 4-man crew, retractable landing gear, 2 powered machine gun turrets for defense, an 18-meter wingspan, a projected top speed of 375 kilometers per hour, a range of 2,000 kilometers, and a service ceiling above 10,000 meters. It promised to be a technological marvel, one that could finally redeem the reputation of the Italian invention. Stipa was thrilled when he learned of the French project. At last, someone seemed to understand the potential of his system for large multi-engine aircraft. But the joy was short-lived. In 1936, the French government began a sweeping nationalization of the aviation industry, merging dozens of small firms into large state-controlled conglomerates. The reorganization buried many promising developments, including the BN-4 bomber, which was canceled before a single prototype could be built. Once again, Stipa was left with nothing but drawings and patents no one intended to turn into metal. Meanwhile, in Germany, engineer Ludwig Kort patented a ring-shaped guide system for propellers in 1934, operating on similar principles. The Kort nozzle, an annular shroud around a marine propeller, boosted efficiency by directing the water flow and proved so successful that it remains in use on ships to this day. Stipa watched bitterly as his ideas found practical application at sea, while aviation stubbornly ignored tubular propellers. The situation worsened with the outbreak of the Second World War, when Germany introduced the V-1 flying bomb. Stipa immediately accused the Germans of stealing his patents, claiming that the missile's pulse jet engine was copied from his in-tubed propeller. In reality, the two systems had almost nothing in common. The V-1's engine operated on controlled explosions of fuel-air mixture in a combustion chamber, producing pulsating jet thrust, no propeller, no ducted fan, no real resemblance to Stipa's design. But the embittered inventor clung to any chance to prove the value of his work, even if it meant stretching analogies beyond credibility.
That said, some German concepts did echo his ideas. Surviving archives contain sketches of a mysterious Heinkel fighter dated around 1940, depicting an aircraft with a ring-shaped shroud around the propeller, strikingly similar to the Stipa-Caproni tube. The project was linked to a special engine by Austrian inventor Victor Schauberger, famous for his eccentric theories about vortices and even flying saucers. It never progressed beyond a few drawings. In Italy, however, experiments with directed airflow continued. In 1940, Caproni unveiled the Campini N1, a far more advanced descendant of the flying barrel. This aircraft used a conventional radial engine to drive a variable pitch compressor inside the fuselage. Compressed air was mixed with fuel and burned in a tail-mounted chamber to produce jet thrust. The system resembled a modern turbojet in concept, though it worked on a different principle. The aircraft flew successfully several times, but proved utterly impractical, too complex, too thirsty, and too slow. Still, Italy claimed the prestige of fielding the world's first aircraft with an afterburner, a small consolation for Stipa. He watched aviation's evolution with growing frustration. His ideas lingered in the air, influencing designers worldwide, yet nowhere found full realization. Every new project was either too complex, too inefficient, or simply unwanted by military and civilian customers. The flying barrel remained the only aircraft ever built with a true in-tubed propeller, a monument to bold but ultimately useless engineering imagination. The end of the Second World War brought a genuine revolution in aviation. Jet engines rapidly displaced propeller-driven aircraft, ushering in an era of supersonic speeds and unprecedented altitudes. Luigi Stipa observed this progress with mixed emotions. On one hand, he celebrated the triumph of new technology. On the other, every turbojet engine he saw seemed to echo his own work. A compressor squeezing air inside a metal casing, a combustion chamber, and expanding nozzle, these elements mirrored the principles of his in-tubed propeller. Stipa sincerely believed that jet aviation had stolen his ideas without giving him due credit. To be fair, some aviation historians did note parallels between the tubular propeller of 1932 and the turbofan engines that emerged decades later. A turbofan operates on a similar logic. Part of the air passes through the compressor and combustion chamber to create a hot jet, while another portion flows around the engine through an annular duct, accelerating as a cold stream that increases thrust and reduces fuel consumption. Conceptually, this resembled Stipa's vision of directing airflow through a tube to improve efficiency, but no direct lineage could be established. Jet engine designers arrived at their solutions independently, guided by thermodynamics and gas dynamics. Stipa, however, remained convinced until his final days that the aviation world had robbed him, and the bitterness of unrecognized genius shadowed the last decades of his life.
The inventor who, in the 1930s, dreamed of overturning aviation gradually turned into a bitter old man, endlessly replaying the injustices of the past. His colleagues sympathized, but few took his claims seriously. The aviation industry had long since moved on, leaving the flying barrel as a curious footnote in history books. Luigi Stipa died in 1992 at the age of 97, never living to see the triumphant recognition he believed he deserved. Yet even after the creator's death, the story of the flying barrel did not end. Far away in Australia, a group of enthusiasts decided to resurrect the forgotten aircraft. Coley and the team at Aerotech Queensland undertook an ambitious project to build a working replica of the Stipa-Caproni, reduced to 3/5 scale to simplify construction and cut costs. The Australians painstakingly studied surviving drawings and photographs, recreating every detail of the bizarre machine. Special care was given to the paint scheme. The replica wore the same blue and cream colors as the original had 60 years earlier. In the mid-1990s, the scaled-down aircraft was rolled out onto the airfield at Toowoomba, and something extraordinary happened. More than half a century after the original, a second flying barrel took to the sky. The aircraft completed 2 flights, proving that Stipa's concept still worked, even in miniature. Pilots reported the same strange characteristics described by Italian test pilots decades before: phenomenal stability, low noise, good climb performance, and dreadful handling. After testing, the Australian replica was placed on static display at Toowoomba Airport, where it remains today, drawing curious visitors with its comical appearance.
Thus ended the story of an aircraft that was ahead of its time, yet utterly useless in the era that produced it. The Stipa-Caproni proved a revolutionary idea could work, but not how to make it practical. Too slow for the military, too strange for civilian operators, too inefficient for mass production, the flying barrel remained an experimental oddity forever. Perhaps, had Stipa received funding for multi-engine versions, history might have unfolded differently. Perhaps his ideas did influence the creators of turbofan engines. But one thing is certain: the Italian engineer built the strangest airplane in aviation history, a machine impossible to forget once seen even once. And in that, perhaps, lies his true immortality. If you enjoyed this incredible story of aviation madness and forgotten genius, be sure to like the video, tell us in the comments which aircraft from the past you'd like to see next, and subscribe to the channel so you don't miss new stories about the most astonishing aircraft of the 20th century. Many more discoveries await.